Okay folks, we're going to look at binomial expansion, and this should be a revision really of AS. So your two different forms for binomial expansion are the one that it's 1 plus x to the power of n, so your bracket starts 1, and it's 1 plus nx plus n upon n minus 1 over factorial 2x squared, plus n upon n minus 1 times n minus 2 over factorial 3 times x cubed, etc. And you get that formula on your formula sheet. The other format of it, a plus x to the power of n. Now, if you don't ever want to use it, it's fine. You can always make your bracket look like the first one. But if you use this one, it's a to the power of n plus n a to the power of n minus 1 x plus n upon n minus 1 a to the power of n minus 2 over factorial 2 times x squared, etc. So you can see the addition to the first one is a to the power of n, a to the power of n minus 1, a to the power of n minus 2, and so on. So we'll start with the first few. And your question would be expand. And we've got 1 plus x to the power of 4. So if we're expanding 1 plus x to the power of 4, we're going to use our top formula up here. So it's 1 plus 4x plus 4 times 3 over factorial 2 x squared plus 4 times 3 times 2 over factorial 3 x cubed plus 4 times 3 times 2 times 1 over factorial 4 x to the power of 4. And then just tidying that up, we get 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. Our next one, 1 minus 2x cubed. Just need to be careful with the minus signs. So it's 1 plus 3 times, this time our x in the formula is minus 2x. So plus 3 times 2 over factorial 2 times minus 2x squared plus 3 times 2 times 1 over factorial 3 times minus 2x cubed. And then when we tidy that up, we get 1 minus 6x plus 12x squared minus 8x cubed. So slightly harder ones now. Number 2, this is find the first 4 terms. So part A, 1 over 1 plus x. So the first thing we have to do is to change that into 1 plus x to the power of minus 1. And then we expand it. Now we only want the first 4 terms, so it's 1 plus minus 1 times x plus minus 1 times minus 2 over factorial 2 times x squared plus minus 1 times minus 2 times minus 3 over factorial 3 times x cubed. And then tidy that up. 1 minus x plus x squared minus x cubed. Part B then, the square root of 1 minus 3x. So you have to know that that can be written as 1 minus 3x to the power of a half. And then we just follow the rule, follow the formula. So it's 1 plus a half from minus 3x plus a half times minus a half over factorial 2 times minus 3x squared plus a half times minus a half times minus 3 over 2 over factorial 3 times minus 3x all cubed. So when we tidy all that up, it becomes 1 minus 3 over 2x minus 9 over 8 x squared minus 27 over 16 x cubed. Okay, so our next one, this is more of an A2 question here. So we're having to find up to x cubed of this expansion, and it asks for the range of values that it's valid. So the first thing we'll do, 1 minus x to the power of a third equals 1 plus a third times minus x plus a third times minus 2/3 over factorial 2 times minus x all squared plus a third times minus 2/3 times minus 5/3 over factorial 3 times minus x cubed. And when we tidy that up, that becomes 1 minus a third x minus a ninth x squared minus 5 over 81 x cubed. And the bit for valid, you take whatever your x is, so our x here is minus x, and we say the modulus of that is less than 1. Obviously it doesn't make sense to have a minus within a modulus sign, so we just change that to the modulus of x is less than 1. Okay, the fourth one then. Okay, so our fourth one, find the expansion of the square root of 1 minus 2x up to and including the x squared term, and find a suitable approximation for root 2. So we know that the square root of 1 minus 2x is the same as 1 minus 2x to the power of a half. So we write that out, 1 plus a half times minus 2x plus a half times minus a half over factorial 2 times minus 2x squared, and that gives us 1 minus x minus a half x squared. So that's the first part, the approximation to root 2. So we'll let root 2 equal the root of 1 minus 2x, which means 2 equals 1 minus 2x, and rearrange that to get a value for x, and we get that x is 0.5. We put that into our expansion up here, so we get root 2 is approximately equal to 1 minus 0.5 minus a half times 0.5 squared. Sorry, that should be minus a half. And when we do that sum, we get 1.375.